you look at page 134, what they're saying is this X, and this is the amount produced. You can think of it produced in the economy as a whole for consumption. And then there's an intermediate demand for that output. And then there's the final demand. And if you're talking about in economics, final demand is what the economy is about. You produce goods and services, and then this intermediate demand is there's firms producing goods and services, but what they require is they require output themselves. There's different sectors of the economy, and they've broken it down. It's pretty common. The non-productive parts of the economy represent consumer demand, government consumption, surplus production, and exports. So those are the people that buy final goods and services in the economy. Now there's intermediate goods and services that are bought by firms that are building product. So what they're saying is that this intermediate demand is part of what has to be built in the production process. And then this is the non-productive part. And when they measure an economy, when they measure GDP, gross domestic product, this is what they're measuring, the final demand, not intermediate. Because what's happening in an economy is all of these, the costs that are involved here are all included in the cost of the final good that's being purchased. If you're running a company and you produce a product, you will buy goods and services to produce the product. But what you will do is you will include that cost into the cost of the product that you sell. And the way you measure an economy, the size of the economy, is what is the final goods and services. Because if you measure intermediate production, then you double count it. For example, I'll just give you an example, economic example. If Goodyear produces tires, if Ethan buys tires for his used car, those tires are a final good. They are counted in GDP. But if Ford Motor buys the same tires you bought to put on your car, to put on their new cars coming off the factory, that's intermediate, because what's going to be, when they sell that car, what's going to be included in the cost of that car? Tires. So that's the intermediate. Right? Same way with all kinds of things. So anytime firms build goods, there's an intermediate demand for goods and services, and there's a final demand. The only one you want to count is the final, because the intermediates are all included in the cost of that final good. And that's what this Lentoff is saying, is that there are these, for the production of goods and services in the economy, there is an intermediate demand for goods and there's a final demand. And then what they do is this, they're going to call this formula, this is the production that all firms are doing. This is going to be a matrix that expresses the demand for the different sectors, and they're going to produce product So every unit that they produce, this vector, they will, from a column in here, they will require a certain amount of goods from all the other sectors that are producing product. So this C right here includes vectors that are costs, and everything's got to be in dollars. You don't do it in terms of units. You do it in terms of dollars. The X is in dollars of production. The C is in dollars of items that are bought from different sectors to produce X dollars worth of product. And then the D, which is the final demand, which is consumers, government, net exports, and investment. So that's what that's going to be. And that they include that. They say that's other goods and services demanded. Consumer demand, government consumption, surplus production. Surplus production is going to be in investment. And then exports. It's interesting in our economy. We have actually, if you're measuring GDP, our exports are net negative. We import more than we export. So we have a net negative export in this country. So, and consumer demand is something like close to 80% of all production that's final goods and services. So when you talk about a GDP of, well, like, I don't know, it's $14 trillion or 15 trillion is the GDP, right? Yeah. So it's that 80% of it is consumers are doing it. That's why when they talk about on the news, you say the consumers are being pessimistic about the economy, then that's affecting 80% of your economy. If they decide to quit buying, we're really hurt because 80% is what they're affecting. And exports is a net, it can be up to a negative 5%. And government's around 15%. It's a little higher now, and investments around 14-15%. And so, that's what, but those are the only things that count toward GDP. And that's what this would be. Final goods and services. Now, in terms of this vector C, each column is going to tell you how many dollars worth of product has going to come from each sector of the economy to produce $1 worth of or 1 unit, which is measured in dollars, worth of output. And if you notice at the top of the page on 135, what that vector is the vector for manufacturing. When it says 0.50, 0.20, 0.10, and it says manufacturing, agriculture, and services. It's saying to produce 1 unit up here, it takes this much from manufacturing, this much of a dollar from that, and that much of a dollar from there. And that's the vector that tells you the cost per unit of output. And then the next one over is agriculture. So 1 unit of output these are what the inputs are. Agriculture, that vector is 0.40, 0.30, and 0.10. So for agriculture, this is how much manufacturing has to input per unit of output. This is what agriculture itself has to produce per unit of output, and this is how much services have to be. Now notice that when you're producing products, these products right here, there's only two kinds of products that are produced: goods and services. A good is something that has some tangibility to it. And a service, you know, like you go to a lawyer and you get a lawyer to help you. What are you getting, a good or a service? You're getting a service. You're going to a doctor, what are you getting? Service. And when they say we're a service industry and they say service people are low paid, that's a bunch of hogwash. A lawyer is a service, right? A doctor is a service. A therapist is a service. Are those low-paying jobs? No. I mean, you hear it on the news, right? We're a service industry, right? They're thinking about people who are serving you hamburgers at McDonald's and all those people. They're services too, and they're low-paying. But one thing is doctors provide services, lawyers provide services. You know, physical therapists provide. There's no good. When you walk out the door, is there any value that follows you along that you can resell to somebody else? Only the information. You can say, this is what, but the only thing is otherwise it's gone. And those are high valued services. So, you know, when you hear people talk about we're a service industry and it's all low paying jobs, it's a bunch of horse manure, right? That's just propaganda. That's a spin put on something. Because we have high-paid services. We have low-paid services. We have low-paid goods, right? McDonald's hamburger is pretty low-paid good, right? Well, yeah, but the only thing is it's pretty inexpensive. Rather than going to some high-end restaurant and you get meat, you can get a hamburger from McDonald's for what? $4 or something just for the hamburger. You can go to a high-end restaurant, pay $25 for that same stinking hamburger. Oh, sure. Yeah. Yeah. I think when you look at the food industry, a lot of dollars worth of food sold, probably low-end dollars are probably not as many dollars as high-end dollars. I don't know. I never looked at that. But, you know, there's a lot more low-end dollar food sold than high-end dollar food in terms of quantity. In terms of dollars worth of something. I don't know. It might. High-end food, probably more low-end food dollars. Okay, then the last one, services. Manufacturing is 0.20. That's from agriculture, 0.1. And other services, 0.3. So, you know, if you go into a doctor's office, there's a lot of equipment in there, right? Well, that's manufacturing. It's coming from manufacturing things. Doctor's providing a service, but you know he requires that. Agriculture products, well, he's if he gives you free samples of medicine, you know, that's agriculture related. If he gives you, if he has gauze or something that he uses to bandage up your thing, that's an agriculture thing. So there's agriculture costs involved in that. at a service, there's other people. He might have a nurse in there, he might have a receptionist, he might have lots of people. Those services all provide part of that. So that's where that is at. So each one of those in this matrix, each vector is a cost per unit of output vector for each of those sectors of the economy. And they're talking about when you do this C, then that matrix is the vector C1, C2, and C3. So the number of units of output of X1, each one of those units will require that vector C1's inputs from those different elements. And how much is produced from, in this case, agriculture, is going to require C2 units of output from the three sectors. And then how many units of C3 is going to require X3, how many units of output of X3 that are produced, it will require whatever that vector C3 is from all of in the production process. So they're saying that X then equals C X plus D. And then they have an example of how to figure out for the production. Theorem 11 is a fairly important theorem. What you do is you take this equation and you subtract Cx from both sides, and then you factor out the x, and what you're going to do is get and then x is going to equal, this is I minus C inverse D. So this vector is going to tell you then how much production you have for final demand plus your intermediate demand. And then they're going to go through a formula for doing a short formula for doing this inverse right here. I'm going to look at that. We'll look at we'll look at the problems. Now in that problems 1 through 4, it says, refer to the economy that is divided into 3 sectors: manufacturing, agriculture, and services. For each unit of output, manufacturing requires 0.1 units of other companies in that sector. So what we want to do is we want to make our C matrix. Then we'll do manufacturing, agriculture, growth, and services. And then this manufacturing, that would be our C1 vector. And when it says it requires 10 units from other manufacturers, it requires 0.3 units from agriculture and 0.3 from services. Then agriculture would be our C2 vector, And let's see. Each unit of output in agriculture requires 0.2 units of its own output. Um, 0.6 units from manufacturing, and 0.10 from services. And then the next one, C3 vector, which is services, is going to reach output. Services, 10 units from other services, 0.6 from manufacturing, 0.6, and then no agriculture products. So that is our C vector, C matrix for the economy. Now what they're asking in number 2, try to saying determine the production levels needed to satisfy a final demand of 18 units for agriculture, with no final demand for the other sectors. So what we have that C vector, and then our demand, it's going to be vector 0, 18, and 0. And what we have to do is we've got to do this. They want to know what the product is going to be. And the equation is I minus C, the identity matrix minus C times X equals D. So what we have to figure out is we've got to figure out this thing right here. So it's going to be 1, 0, 0, 1, 0. Minus our C, which is 0, 1, 0. So then when you subtract that, you subtract it item by item, so it's going to be 0.9 minus 0.6 minus 0.6, and then it's minus 0.3, and then it's going to be 0.8, and this is 0, negative 0.3, 1, and 0.9. And then what we're going to do is we're going to augment that matrix. We're going to do this. We're going to do I minus C in P. .9. And then augment it with that 0.18. Now the first thing we do is make it so that we don't have to deal with decimals, so we just multiply everything by 10. So 9 minus 6 minus 6 and 0 minus 3, 8, 0, 18, 3, 1, minus 3, minus 1, 9, 0.
That's the other question. So you're multiplying the entire matrix by 5.
Yeah, I did. Thanks. I meant to, but I didn't. Thanks for getting that. Now the question is, how are you going to approach the problem? You know, we're going to have a diagonal of ones. We can choose to divide the first row by 9 and then get fractions and deal with the fractions then, or else we're going to have to deal with fractions as we multiply, because, you know, we'd have to take 1/3 of 9 to get rid of the 3, and then we'd have to multiply it all through there. I don't know, which way would you rather do it? If we left it and did 1/3, notice that the second one here would turn out to be a 2 and a 2, and we'd be subtracting whole numbers from each other. We left 9, then left that 9 to be divided out at the end. So that's the process I'm going to do. I'm going to go 9 minus 6 minus 6 and 0. Then I'm going to take 1/3 of the first row, and that will get this one 0. And 1/3 of minus 6 is a minus 2, so that makes this 6. And 1/3 of a minus 6 is a minus 2, so that makes this a minus 2, and this is 180. Then I'll do 1/3 of it again, so I'm going to get 0. And then this is minus 2 minus 1 is a minus 3. Minus 2, 7, 0. Now, on that, when I eliminate this minus 3 down here, if I stay with fractions, then, you know, it's going to be half, and half will work the whole way through. So 9 minus 6 minus 6 and 0. 0, 6, minus 2, and 180. Then I'm going to take half of the second row, and that'll make this 0. 1/2 the second is a minus 1, so this is 6. Half of the second is 90. Now I think it might be beneficial to divide the bottom row by 6. Because otherwise I'd have to I'd take a third. Well, maybe it'd be simpler if I just took a third. Maybe if I just left it that way. So I'm going to go 0, 0, 6, 90. Then to eliminate that minus 2, I take the bottom row times 1/3, and then I'll make this 0. 1/3 of 90 is 30, and that'd be 210, wouldn't it? Then I'll go 9 minus 6. Now I take the bottom row times 1, that now I just take the second row. I'm gonna divide this bottom row by 6 because I'm done with it. 1, 6 into there, what's 1, is that 15? But I'm going to leave this alone. And just multiply it by 1. So go. And now that's 300, right? I'm going to divide the top row by 9. 1, 0, 0, 9, 18, 27. 3, and that's 30. So it's 33 and 1/3, right? Divide this row by 6. 1, 3, 5, 0, 0, 1, 15. Now if I've done all my math right, then my total production X that's necessary is going to be 33 1/3 agriculture, manufacturing, 35 agriculture, and 15 of services to produce 18 agriculture, right? Okay, let's look at 4. Determine the production levels needed to satisfy final demand. 18 units of manufacturing, 18 units of agriculture, and 0 units of services. So, we're going to have to do this. Get this I minus C. And just like we did before, because what we're doing is this. We're doing I minus C X equals D. So then we're going to augment the I minus C with the D and find it where D is going to be 18, right. 18 units of manufacturing, 18, and 0. We've already got this I minus C, and that's that. .9 minus minus 0.6, minus 0.6, minus 0.3, 0.8, and then it's 0. It's a negative. And we'll, the D is actually 1818. It's 18, 18, and 0. So we'll augment this with an 18, 18, and 0. Then I'm going to multiply by 10, so that I get the 9 minus 6 minus 6. 1, 8, 0, minus 3, 8, 0, 1, 8, 0, minus 3, minus 1, 9, and 0. I think I'm still going to do the 1/3. 9 minus 6 minus 6, 180. So it's 0, negative 2, 6, 2, 16, we're adding 240. Then 1/3 again is 0. Minus 3, 7, 1/3 of that is 60. Nine minus 6 minus 6. And I'll do half of this row. 0, 0, 6. That's 120, that's 180. No, I better add. Yeah, that'd be 180. Half of 240 is 120, add 60 is 180. I'm going to take 1/3 at the bottom. So how do I get rid of the clock today? Tell me X out of this. Does that silly clock have a X? Just a mouse and click on it? Okay, thanks. So I'm just going to leave that bottom row the way it is. I'm going to take 1 times the bottom row, 0. And that's 360, isn't it? 6. I'm going to take 1/3 of the bottom row. And it's going to be 0. And 300. And then the bottom row I'm going to divide by 6. So I'm going to take 1 times the second row, 0, 0, so that's 660. Now divide 6 into the second row. Then divide the top row by 9. One, 0. So what do I get? 74 and 1/3. Is that right?
73.
73 and 1/3. Okay. Zero, 1, 0, 50. So to produce 8 units of manufacturing, 18 units of manufacturing, 15 units of agriculture. It takes the production of 73 and 1/3 of manufacturing, 50 of agriculture, and 30 of services. And I think that's what they wanted. Determine the production levels needed to satisfy the final demand of 18 units of agriculture or manufacturing, 18 of agriculture, and 0 units of okay. So number 6 says repeat exercise 5 with C is equal to that. And D C equals 0.1, 0.6, 0.5, and 0.2, and these 18 and 11. So they're saying use an inverse matrices to determine the production level necessary to satisfy the final demand. So this one is using the inverse matrices, not augment the matrix. So what they're saying is this: if we got this production, and then we move that over, it's x minus cx equals d. Then I minus c x equals d. So they want us to do it that way. They want us to take this thing times this to get x, rather than doing this and augment it with the d to find x. They want to do the I minus c inverse. So what we have to do is we've got to find we have to find the I minus C. 1, 0, 0, 1 minus C is 0, 0, 6, 0, 5, 2, which is going to be, okay, this is going to be 0.9 minus 0.6, 0.5 minus 0.2. No, take that back, 0.8. 1 minus 0.2 is 0.8. Now we want to find the inverse of that. Now you either have to do it as 1 over the determinant, do it that way, or else you get, but I prefer to, yeah, this would be a minus 5. Thanks. 0.9 minus 0.6 minus 0.5, 0.8, 1, 0, 0, 1. This is the I minus C I, and then we want to convert it into I and I minus C inverse. And that matrix converted into this matrix. Okay, first thing I'm going to do is I'm going to get rid of those decimals. So I'll multiply 10 times everything. So this is a 9 minus 6, 10 and 0, minus 5, 8, 0, and 10. Now I want to get I on the left. So I'm going to have to take 5 ninths of the first column. So I get 9. Either that or else you can divide 9 into the first column to get 1 up there. And then deal with fractions that way. Which way do you want to do it? What?
Sorry.
Do you want to divide 9 into this first column to get this in fractions, so that you get 1 in place of the 9 and then eliminate, or do you want to take fractions times it to get rid of, or trying to get rid of this? I guess for giggles we can do it. Divide 9 and see what kind of a mess that comes out to be. That would make this 1. What's that? This is 1. Negative 2/3. And then this is 10 ninths. And then it's 0. I'll just go ahead and take minus 5 times that. 5 times the first row. That would make this 0. I'm gonna take, no, I better do this. Because when I try and do it the other way, I get confused sometimes. So I'm gonna take 5 times the first row. 2 thirds, 10 ninths, 0. Take 5 times the first row, that makes this 0. So that's a minus 10 thirds. So it's 8 minus 10 thirds. No matter how we do it, we're going to end up with this mess thing like this. So it's 8 minus 10 thirds, 3/3. So that's 24 minus 10, 14 thirds, and that's what I put in here. And I'm multiplying 5 times the first row, so that's 50 ninths. And then this is still 10. I think I'm going to make that 14 thirds of 1. So it's a 0. This is going to be 1 because I'm taking 3/14. So this is 50 over 4 times 3/14. That's 7/25. That's as low as I can go, isn't it? So that's 75 over 28. And then we're taking 10 times 3/14. 7, 5. So that's 15, 17 over 7. I tell you, no matter what way you do it, it's going to involve some fractions. So now I take the bottom row times 2/3, right? 1, 0. And then this is, that was 75/28, wasn't it? 25. So that's 25/14, isn't it? And I'm adding it to 10 ninths, right? Correct? Is that right? It's not, yeah, not pretty. Plus 25/14, which is 7/5. Nothing, we don't reduce any further, does it? Oh, we gotta get a common denominator. No, I did this wrong. Don't look at that. Because I can't divide across the addition sign. The common denominators, this has to be multiplied by 14 over 14 and 9 over 9, right? That's the only way it works. So that's 140 plus, what's 9 times 25? 225 over 14 times 9. 365 or 14 times 9. Now, does that sucker divide out? There's no common 3s, there's no common 2s or 7s, is there? Oh boy, that's pretty awful. So that's 365 over what? I hate this problem. And now it's 2/3 times that 15 sevenths. 2/3. 10 sevenths, right? 10 sevenths. 0, 1, 75, 28. 15 sevenths. Oh. I think there's something wrong with what we've done so far to get this. Okay, let's just go back over it. Because you're going to have to do one of these things, so we better figure out. From here to here, we're good, aren't we? Multiplied by 10. And then divided by 9. 5 times the first. I think there's something wrong here, isn't there? This right here. 24 minus 10. And I got 14, and no, that's 14. Thirds, okay.
That's fine. Next equation. So you multiply by 3/14. Let's see. I wonder if that's right.
You think our problem is here? Well, it looks good to hear to me, don't it? You? I'm gonna erase all this stuff to go down underneath. Redo that last thing. So what we have to do is we have to multiply the last row to get rid of the minus 2/3, right? So it's 1, 0. So we're multiplying the last row by 2/3 and adding it to 10 ninths, right? 10 ninths plus 2/3 of 75 over 28, right? Is that right? So 3 is going to go into 75 25 times, isn't it? 2 into there is 14 times. So we get 10 ninths plus 25 14ths. Now we got to get a common denominator, and there's the 9 and the 14 share no common factors, right? So it's got to be 14 over 14 and a 9 over 9. So this is 140 plus, that's 225, isn't it? Over 14 times 9. So that's 365. Man, that silly thing runs together. Over 14 times 9. Did we say there was any common factors? 3 is not a factor of the numerator. 2 or 7 is not a factor. So this is 365. 8. Is that right? What? 126? Okay, okay. So what did I say? 365 over 126. Yeah, that's the same thing we were getting before. So is the last one, is that last one right? Okay. We just have a 0. So it's just 15 sevenths times 2/3. 5. So that's 10 sevenths. I'll be dang. That is ugly, isn't it? What? So that's the inverse of C, right? That's just the inverse of C. Then we got to go. Oh yeah, it's the inverse of 1 minus C inverse. So, I minus C inverse is equal to 365 over 126 10/7, 75 over 28, and 15/7. Now what we have to do, but I know we're out of time. But you see, we have to multiply I minus C inverse times B. So we're going to have to put this matrix B out here and then do the multiplication. Tedious. It's a whole lot easier to augment the matrix, you know, and do it. Okay.